How do you calculate entropy of mixing in thermodynamics? Have you ever wondered what happens when different substances come together? The concept of entropy of mixing plays a key role in understanding this phenomenon. When two or more different substances, like gases or liquids, mix without any chemical reactions, the entropy increases. This increase occurs because the molecules gain more possible arrangements, leading to greater disorder in the system. To calculate the entropy of mixing, we use a specific formula that involves the mole fractions of each component and the gas constant. The formula for the change in entropy due to mixing is represented as delta's mix. It is expressed as delta's mix is equal to nr x1 lane x1 plus x2 lane x2 plus xn lane. In this equation, n represents the total number of moles of the mixture. R is the ideal gas constant. The terms x1, x2, and so on are the mole fractions of each component in the mixture. The lane symbol stands for the natural logarithm. Since mole fractions are always less than 1, the logarithms will be negative. This results in a positive overall entropy change, indicating an increase in entropy when substances mix. To visualize this, think about mixing two gases. If each gas starts in its own container and then the barrier is removed, each gas expands into the total volume. This expansion increases the number of possible arrangements for the molecules, which raises the entropy. For two gases, A and B, that are initially separated, we can express the entropy change as delta's mix is equal to NAR ln, Va plus VB slash Va plus NBR ln, Va plus VB slash VB. Here, Va and VB are the initial volumes of gases A and B, while Na and are the moles of each gas. Using the ideal gas law, which states that pressure times volume equals the number of moles times the gas constant times temperature, we can relate volume to moles. This allows us to rewrite the equation as delta's mix is equal to NAR ln, NANB slash Na plus NBR ln, NANB slash NB. This calculation assumes ideal behavior, meaning the gases do not interact chemically and mix spontaneously. Understanding the entropy of mixing is important because it explains why mixing occurs spontaneously. This concept is relevant in various fields, including chemical engineering and physical chemistry. It also ties into the second law of thermodynamics, which states that systems naturally evolve toward states with higher entropy. To summarize how to calculate the entropy of mixing, first determine the mole fractions of each component. Then, apply the formula delta's mix is equal to nr sigma She lane. This calculation reflects the increase in randomness when substances mix without undergoing chemical reactions.